Exalted by the beauty of the solar system on one side and the sheer size of the lunar system on the other, our universe is one big ball of mystery. And for all our years of space exploration, one would actually think we've gathered enough knowledge about these two systems. But that's not the case. On the contrary, there's so much hidden secrets about them. But thankfully, we'll be revealing some of them today. Join us as we explore the inner workings of the solar and lunar systems. Piece by piece, scientists have tried to unravel the enigma behind our universe and some of its most significant elements, like the solar and lunar systems. And it's safe to say most of their discoveries in this line of study have been downright fascinating. Of course, it's impossible to discuss the solar system without referencing our very own sun. This massive fiery ball of flames is a yellow dwarf star situated some 150 million kilometers away at the center of the solar system. The sun is scorching, with a temperature that ranges from 5,500 degrees Celsius to 15 million degrees Celsius. It's also quite big as well. It's the largest object in our solar system, with a diameter of approximately 1.4 million kilometers, and this means that its size and mass are absolutely intimidating compared to the planets in our solar system. To put this in perspective, the sun is as heavy as 330,000 Earths, and big enough to accommodate 1.3 million Earths. Scientists say this intriguing star has existed for about 4.5 billion years. But its importance to our planet hasn't dwindled one bit. The sun supplies the gravity that holds the solar system together. It keeps all elements, including the biggest planets and even the smallest bits of debris, in their rightful orbit, which helps to avert potential disastrous collisions in the solar system. More importantly, the energy generated by the sun is important in many ways to our existence on Earth, and without it, life, as we've come to know it, on this blue planet, could not exist. But for all its mightiness and importance, the sun is just one arm of the solar system. Speaking about arms, the solar system itself is an outer arm of the Milky Way galaxy. Critically, our universe contains many other planetary systems like ours, with multiple orbiting planets and a host star. But ours is named the solar system because, as humans, we like to use the word solar to describe anything related to our parent star. As the centerpiece of the solar system, our sun is surrounded by planets and millions of smaller celestial bodies like dwarf planets, asteroids, comets, meteoroids, and 176 moons. These planets include Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and until recently, Pluto. Pluto was demoted in 2006, hence it's no longer regarded as a planet. Astronomers tend to classify the planets in our solar system into two categories called the inner planets and the outer planets. The inner planets are a set of 4 planets, including Mercury, Venus, Earth, and Mars, located within the frost line, which is about 700 million kilometers away from the sun. This phenomenal line, otherwise known as the Goldilocks zone, represents the boundary in the solar system where conditions are warm enough that hydrogen compounds such as water, ammonia, and methane can exist as a liquid. Mercury is the closest to our sun and the smallest member of the inner planets group. It shares most of its characteristics with the Earth's moon, particularly in color and deep craters. Mercury has a very thin atmosphere, meaning it gets sweltering during the day, up to 430 degrees Celsius, and very cold during the night, about 187 degrees Celsius. This is mainly because its atmosphere cannot absorb or emit heat. Furthermore, Mercury has no moons of its own, and its magnetic field is only about 1% that of our blue planet. The next inner planet, Venus, is about the same size as Earth, but it features extreme temperatures and unusual brightness that make it the hottest planet in the entire solar system and the second brightest object in the night sky after our moon. Venus has dense clouds which consist mainly of sulfuric acid and other corrosive compounds. Also, its atmosphere comprises 96% carbon dioxide and other elements and gases like nitrogen. Like Mercury, Venus has no moon of its own, and its atmosphere is so thick and hostile that only 2 spacecraft have been able to explore it. Up next is our very own Earth, which so far remains the only planet in our solar system that is known to harbor liquid water and sustain complex life. Earth is the largest of the 4 inner planets. Unlike Mercury and Venus, it has a moon of its own and a healthy atmosphere which protects the planet from dangerous radiation. This atmosphere is also responsible for absorbing the right amount of sunlight and heat to support the existence of life on the planet. Lastly, we have Mars, the 4th and final inner planet, which is sometimes called the red planet because its surface is made up of iron-rich materials. Mars has quite a number of interesting natural features, and is also believed to be one of the candidates among the inner planets that could possibly support life as we know it on Earth. The Olympus Mons, which ranks as one of the most stunning features on Mars. This gigantic edifice is the largest mountain in the solar system, rising to 69,949 feet above the surface. There's also a giant canyon known as the Valles Marineris, which covers about the same area as the entire United States. Mars is less dense than Earth and has a smaller magnetic field. Also, it has two small moons called Phobos and Deimos, and has seen several probe missions from Earth. Aside from their proximity to the Sun, inner planets are rocky and terrestrial. And as revealed earlier, 3 of them, including Venus, Earth, and Mars, have atmospheres substantial enough to generate the weather, but all 4 of them have impact craters and tectonic surface features like rift valleys and volcanoes. In addition, they have few or no moons circling around them. Outer planets, on the other hand, are gas giants such as Jupiter, Saturn, Uranus, and Neptune. Jupiter is the first member of the outer planets and the biggest planet in our solar system. According to reports, this incredible gas giant is twice as massive as all other planets in the solar system combined. Next is Saturn, the beauty queen of our solar system, surrounded by a stunning and complex system of icy rings. Rotating at a nearly 90-degree angle from the plane of its orbit, the next member of the outer planet, Uranus, has a unique tilt that makes it look like it's spinning on its side. And lastly, we have Neptune, the 8th and most distant planet orbiting our Sun. Its dark comes and is constantly whipped by supersonic winds. Generally, outer planets are spaced far apart compared to inner planets. For comparison, the distance between the orbits of Jupiter and Saturn is bigger than the radius of the entire region that accommodates inner planets. Also, outer planets are bigger and less dense than inner planets, and significantly, they have dozens of satellites and rings. Aside from planets, our solar system also accommodates small celestial bodies like dwarf planets and asteroids. Dwarf planets are similar to planets. They have an oval shape and orbit the Sun, but they don't have enough gravitational power to clear their orbital path. Currently, the International Astronomical Union officially recognizes 5 dwarf planets: Ceres, Pluto, Haumea, Makemake, and Eris. The largest of them all, Ceres, is located in the main asteroid belt between Mars and Jupiter, while the rest can be found in the Kuiper belt. Interestingly, astronomers believe that the main asteroid belt potentially contains millions of asteroids and other remnants that we haven't discovered just yet. But as our space exploration efforts continues to advance, cosmologists believe that many of them will be discovered sometime in the not-too-distant future. This brings us to our next point of call, which is the lunar system. The lunar system is contained in the solar system. Basically, the entire lunar system is just one of the 176 moons that exist within the solar system. But the sheer amount of data and knowledge we've gathered from exploring it is absolutely fascinating. Since the inception of our planet, the moon has been our closest companion, and deservedly, it is the easiest celestial object to spot in the night sky. The rhythm of its phases has guided humanity for millennia, playing a significant role in determining the type of seasons we experience, the length of our days, and how our calendar is shaped. So it's only fair that it's one of the most visited places in outer space. Neil Armstrong and Buzz Aldrin were the first astronauts to land on the lunar surface in 1969. Since then, 5 more successful missions have traveled to the moon as part of the Apollo space program. In total, 382 kilograms of rocks and soil samples were brought back to Earth during the entire duration of this mission. With a diameter of 3,475 kilometers, our moon is the 4th biggest moon in the entire solar system. It has a very small iron core, about 680 kilometers in total. Its atmosphere is very thin as well, meaning a layer of dust or footprint can sit on undisturbed on its surface for centuries. But at the same time, this thin atmosphere means that heat cannot be held or absorbed near its surface. As a result, the temperature on our moon ranges from 134 degrees Celsius during the daytime to minus 153 Celsius in the night. Critically, the solar and lunar systems are interconnected such that they sometimes tangle in a phenomenon known as the lunar eclipse and the solar eclipse. When eclipses occur, the moon, sun, and our Earth are positioned on a straight line, or nearly so. If it's a lunar eclipse, The Earth would be positioned directly between the Sun and the Moon, which ultimately casts the Earth's shadow onto the Moon's face. Admittedly, the lunar eclipse can only occur during a full moon. Meanwhile, a solar eclipse can only occur during a new moon. A solar eclipse, on the other hand, happens when the Moon passes between the Sun and the Earth, casting the Moon's shadow onto Earth. A solar eclipse can either be total, annular, or partial, but the chances of experiencing a total eclipse in a given location are incredibly low because the shadow of the Moon is so small on the Earth's surface. These are just some of the little-known details about the solar and lunar systems. And we dare say that many more interesting facts and mysteries will be discovered about these systems in the coming years, even as we continue to beam our searchlight across the length and breadth of the cosmos.